So we don't start for 10 minutes, but as usual, I like to talk about the news when we got dead time like this. So American Airlines is suing to halt all US to China flights. I know Britain just canceled all flights to China. I'm just amazed by this. I mean, the ordinary flu kills 30,000 people a year, and China seems to be taking very extreme measures far beyond what appears to be the risk. I mean, they canceled DEF CON, they canceled all public meetings for 6 months. That's going to cost them a ton of money. And I wonder if it's justified. I mean, it doesn't seem like it's that big a deal, but maybe so. Anyway, everybody is freaking out about this coronavirus. So if you're in China, they are buying masks for their dogs to protect them from coronavirus. So I guess dogs might get it too. Supposedly it came from bats. I guess dogs might be at risk. So the US government is pushing for backdoors into phones again. And as usual in politics, they discovered that people have a bad reaction to the word backdoor, so they're trying to come up with other words, but that's what they mean. And that's the way all phones used to be until about 5 years ago. Every product, the manufacturer had a secret way in, and you could go to the manufacturer with a receipt or court order, and they could get in, including Apple. You could just mail the phone to Apple with a court order and pay a $300 fee, and they would take all the data off the phone and send it back to you. But about 5 years ago, they encrypted their phones, so they can't do that anymore. And the FBI thinks they shouldn't have. However, they have the legal right to do that in America. They cannot do that with normal telephone calls. There's a law called CALEA, which forces the phone company to give assistance to the police to wiretap phones. So you cannot sell any phone service without having some way for the cops to wiretap it. And they would like to have that for cell phones and the internet, but they don't have it yet. So people are arguing about it. Of course, this is all purely symbolic, purely for image, because you can totally get in. All you have to do is go to the hacking companies, Elcomsoft, Celebrite. There are a series of high-powered companies. Celebrite announced in June they can hack into every iPhone. You just break their security and get in. Their security is not really that strong, and the fact that they do not have an authorized way in just means you break it to get in. It just means the government has to buy these hacking tools, and you're getting them from other countries, and Apple has no control at all, which is a standard security issue. If you make a security policy that is so extreme that people can't do their job, they will just break the rules. So if you don't give people some reasonable way to do what they need to do, they will thwart your security entirely, and then you've lost all control. But that's where Apple is. Apple is locking everybody out, so they're just hacking it. So it's a little unclear what that accomplished. Yeah.
So even though it's encrypted, it's still hackable.
Because they made mistakes. Yeah.
It was a mistake, but Celebrate?
Yep, Celebrate and Elcomsoft and Gray Key are companies that make products that hack into iPhones. And so what it means is, if you could be, these people would tell Apple about the flaws, but if they did, it would put them out of business. So it's just like the NSA develops flaws and then they don't tell anybody because they want to use them to hack people. It's a curious arrangement.
So Apple's security is not much protected like before.
Well, no, I think Apple's security is quite good, but nobody is perfect. These are the top hackers. Top hackers can get in anything. Apple keeps a lot of people out. Most criminal gangs would not be able to get in. Yeah.
I have a new phone. It's a Verizon line. I've had it about 3 weeks. Today I had 14 beep.
14 what?
Beep. So that's at least 15 updates in the last 3 weeks.
Oh, yeah.
Is there something special going on right now that you've heard in the news?
Is this an iPhone? Is it an iPhone or an Android?
It's an Android.
I don't know. What I do know about Android is that the updates are typically not available to you. Unless you got the newest, most expensive phone, the carriers block the updates.
Which model do you have?
It's an LG.
LG?
Samsung?
No, it's LG Android. So it must be coming from LG telling Verizon to update this particular model or models.
Yeah. See, the carriers can write updates and Google makes updates, but the problem with Google updates is they often give you valuable features for free, so carriers block them so they can charge you for those features. So it is, that's the problem with the Android ecosystem, is that there are several stakeholders that don't agree. In the Apple ecosystem, you're getting it straight from Apple and they don't have any incentive to block the updates. They don't let anybody block the updates. So Apple's machines are typically up to date. Android machines are typically 2 years out of date. And that is your largest security vulnerability. They're typically well-known exploits with free code you can download that will just totally take over your Android phone because it's 2 years out of date. Unless you get the higher-end Androids that actually update quickly. That's the worst thing you can ever do for security, is not put on the updates. And most Android users can't. That's why a lot of Android users hack their own phone, take over root control, and then they can put in hacked updates. And now they're in control of the updates. So if you're technically smart enough, you can put on the updates with no restriction. But then you take the responsibility of managing the updates yourself, and most people are not ready to do that. Anyway, public Wi-Fi, in the old days, you would use unencrypted Wi-Fi and you'd use unencrypted websites. So your password and everything would just be spraying around. Now almost everybody uses HTTPS, so that gives you some protection. I thought this is kind of funny. This guy said, because of HTTPS, there's nothing to worry about on public Wi-Fi. Well, I thought that in 2010, I went to DEF CON and used their Wi-Fi, and people got in my account, and I got on the wall of sheep because HTTPS was not used correctly, and it's often not used correctly now. I tested 11% of Android apps don't use, well, 5% of them don't use HTTPS correctly for iPhone apps, and a similar amount of Android apps. So, you know, if it is used correctly, it will protect you very well, but it's often not correct, and you don't have any way to know that. Anyway, however, it's a lot more safe than it used to be. It used to be that you're just sending your data with no encryption at all over the place, and that's even worse. So the QAnon, which is the far right Trump supporters that have this whole crazy religion about strange political things, they've also pushed this bleach. I've heard this for years. People say you should drink bleach, it will cure AIDS, it will cure diabetes, and now they'll say it'll cure coronavirus. All the doctors say, drinking bleach is bad for you, don't do this. But this is it must be 20 years ago, they said they would take your blood out, bleach it, and put it back in, and that would cure your AIDS. It's been a really old idea that bleach is disinfectant, it will cure what's bad for you. Apparently, this is not a good idea, but it's a persistent belief.
Trying to find idiots to do it.
Yeah, well, I mean, especially if you have an incurable disease, right? Now you're ready for desperate measures. Anyway, so I was very impressed with this argument he came up with. I was waiting for this argument. This is exactly what medieval kings thought, and that's basically what Trump is, and that's basically the followers treat him. They worship him as the king. They say you should be loyal to him. He's allowed to do anything he wants. Stop picking on him, and it doesn't matter what he does. And that's the way you were supposed to love your king in the Middle Ages. And Dershowitz explained it in court. He said, Trump wants to be reelected. It is a good thing for him to be reelected because he's a great president. Therefore, it's not selfish or corrupt for him to rig the election to win. He's serving the country by making sure he'll get back in there. I was waiting for this argument. This is exactly what King Louis XIV said in France. At that time, the king is French. Anything that benefits the king is good for the country. And I was waiting for that. He's just stating a very common medieval royalty belief. Now, that's not very consistent with the American Constitution, but it certainly is the way Trump supporters feel about him. Anyway, so this hit the news a few months ago. They paid for a penetration test of a courthouse in Des Moines, and these guys showed up with lockpicks and snuck into the building and got caught, and then they jailed them. And they did not accept the fact that they had a real contract and they were approved to be doing an official penetration test, and they've been waiting for months for it to be resolved, and now they have finally decided to drop charges. And this is a big issue. It's a big part. We teach lockpicking here. They were doing it yesterday. Liz teaches. It's a big part of penetration test is sneaking into buildings. It's a common thing you do. And if the cops and the courts are not on board with it, you can have trouble. You're not supposed to have trouble. You're supposed to carry a get out of jail free card, which is your contract. And when they grab you, then you show that to them and they realize you're part of an authorized test and you're not really a burglar. But of course, some people don't get it. Anyway, there's a new flaw without much details here that supposedly been patched that would let you take over Azure machines and elevate to administrator and move from one Azure machine to the next. So apparently there was some huge flaw there, something like one of these RDP flaws, and they patched it and they are not releasing all the details yet. This is the big concern about cloud computing, is putting all your stuff on the cloud. People are worried that it's not safe. And in practice, there are huge disasters over and over and over. The most common one being you put a database on the cloud and you don't put any password at all, and the whole world can just read it. That seems to happen about every day. But many other flaws also happen on the cloud. Kali has changed their default credentials. Some students who downloaded new versions of Kali Linux for my classes found out it used to be root and tour. Now it's Kali and Kali. So I put that in the project. They've had the same password for about 10 years and they just changed it, which caught people off guard. I hardly use Kali anymore. I just use normal cloud Debian machines because I don't really need all the tools in Kali. But in the pen testing classes, you really need Kali, and we do use it for a few of my projects. All right, and this one is the last one I'll do, quite relevant to us. This web service you sign up for, and it will then watch dumps of stolen passwords, and it will tell you when somebody at your company has had their password stolen. So it will inform you, which is pretty nice. And I think it's like Have You Been Pwned is a similar service that has a dump of all the stolen passwords. You can check to see if your password has been leaked. And somebody told me that at one of the companies a student works for, they subscribe to another one of these services. And when your password leaks, it sends an email to everybody at your company with your password in it. And I think that's a little extreme. This one says your password is leaked. It was an 8-character password. It doesn't put your password in the email and tell everybody. That seems unnecessary to me. But anyway, all right. So let me show you where we're at. This is 129S, and we've been through the first couple chapters here. Here's the videos of the previous class, and we're going to finish up chapter 3 with web application technologies, and then I'm going to demonstrate some projects. I put ZAP back in here. Z-Attack Proxy I wasn't able to do, but now I can do it on the cloud. So I'll show you that tonight. All right, so let's go to the slides, which are here. And I think we're up to this one. All right, we got this far last time. So, all right. So you have, in the old days, you would have static content, HTML files and images just sitting on the server, and people would type in the domain name and they would just all see the same page. That's Web 1.0, just delivering pages the way broadcast TV shows the same thing to a whole bunch of people. Nowadays, it's customized on the fly with a content generation engine like WordPress or other ones that is making a custom page for every user. So it has to read cookies from you to figure out who you are. And then it shows everybody different ads and different specials and different prices on Amazon and so on. The page, your browser thinks it's just loading an HTML page, but it's not. It's loading an automatically generated content by a content management system at the other end. So this means you send a web request, you don't just send like Amazon.com, you have to send a bunch of extra data so it knows more about you to customize the page. So you can put it in the query string, you can have question mark, A equals this, B equals that in the query string. You can put it in the folder names of the URL. Parameters can be put in there like folders. The most common place is in cookies that can just have long strings of data. Or it can be elsewhere. In the body of request, you can just have many parameters going up with post, and typically at a normal modern website, you have all these things happening. So in fact, let me just to be concrete about this, let's take a look at a real one. Here's a browser, and let's set it to go through a proxy. So let me just turn on burp, which is the proxy we're going to use mostly, turn off intercept, and it's 127.001.80.80. I think that'll work under these conditions. Let's give it a try. So I go here to preferences, and then I find proxy, and I tell it to use 127.001.80.80 and use it for all protocols. So now all traffic that this browser generates will be sent through burp. And now if I try to go to Amazon, well, first let's go to insecure site, ad.sam's class. Okay, this is an unencrypted page, which is why it shows you a / shoot a padlock. And unencrypted pages will work fine here. So it will, there it is. It has a request. So it just sends a request, gets a skull image, and here's what the request looks like and the response. So that's a normal unencrypted page. Now, if I try to go to Amazon.com, it's going to tell me that it can't make a proper HTTPS connection because burp is in the middle and burp sends a fake certificate, and that certificate is rejected by my browser. Now I could approve it and then go to Amazon, but what I'm going to do is go to my fake Amazon. I made a fake Amazon page. Somebody else wrote it, but I put up a copy of it called Hackazon, which simulates Amazon and looks like, and this is actually running over HTTP. So I'll use that and we can see Hackazon load. So this is what happens when you load a page. It sends a GET request, and then when it gets the original response, it gets a bunch of HTML, and that has a bunch of other objects it has to load, some JavaScript and many JavaScript pages, and down here there'll be something else happening here. So here's what the request looks like. And you can see this one first didn't send much. The only cookie it sent up was a PHP session ID. But if I log in to this page, it will add more and more. So all these extra parameters are being sent up there. So here it is sending an E tag. It sends various extra parameters for each one. All right, those are responses. Here's the request. So there it is sending a cookie, a GA cookie, and a PHP session ID. This is a very simple page. Real Amazon sends many cookies back and forth. Some are encrypted and some aren't, and it's pretty complicated. All right, so some of those cookies tell who they are after you log in. Some of them keep track of who you are even when you're not logged in. And that's how they target ads and know everything you're doing. There was a news article recently where a guy he quit using Facebook years ago, but he went to the Facebook information page and said, what do you know about me? And Facebook still knows everything he does because they put cookies on your machine and every page has a Facebook button. So even if you don't use Facebook, they've still marked who you are and they're still tracking everything you do. Facebook and Google know everything about everybody, and there's essentially nothing you can do about it. Anyway, even if you're not using their service or logging in, they still mark you and they keep track of your IP address and other things because their whole profit model depends on knowing everything about you so they can target ads. And they do it very efficiently, and there are essentially no laws regulating this practice in America. All right, so you can use any part of the HTTP request as input, like the user agent is supposed to just tell me the name of the browser you're using, but you could put information in there. You can write a server that reads any part of the request and uses it. There's nothing to prevent that. There are just traditions that you should use parameters in the cookie and parameters in the URL as the main information. So on the server, you can write a script in any language you like PHP, VBScript, and Perl, and that script will ask for properties of the request, like the user agent and the URL and the cookie and everything else, and it can just do anything you want with it. And there are many of them, ASPNET and Java. The web server is Apache or IIS or Netscape Enterprise, but I don't think that's common anymore, but that's the server that hands out the pages. But you can write scripts which use information from anywhere in the request, and you can have a database full of other information, which you typically have, and you can just combine them together, and you can have directory services and requests in different formats like XML and SOAP that ask for just a small object instead of a whole web page. And that's what's going on, especially on cell phones. It's requesting a little bit of data to put here and a little bit of data to put here instead of just loading one static page, which is the old-fashioned technique. Java is, I've seen people say it is the highest paid programming language to learn. As you know, if you study Java, it's confusing to write and complicated, but companies pay for it because if you just want to make a simple website, you use PHP. But if you want to make a real big business that's going to be multinational and have thousands of servers, then you got to use Java. Java scales to big time. So big companies have to use it. It's a lot more difficult to develop in, but it scales to size. So Java developers are in high demand by big companies. And Java, of course, is platform independent. It runs equally badly on every platform, which is another big thing that enterprises want. They don't want to have to redevelop their page for a different platform. And Java runs in a Java virtual machine, which runs on every platform, although it runs pretty badly everywhere. It's difficult to set up, difficult to maintain, but you accept all that because it's not for amateurs, it's for professionals who are willing to work hard to set it up, like Cisco routers are similar. They're very confusing. The components are strange. The manuals are strange. The updates are hard to get. They are not for home users. They are for enterprise users who are willing to have somebody that really studies it and works hard to keep it going. So you got enterprise Java Bean and plain old Java objects and Java servlets. And these are various objects you create in the Java space. And there's a whole fleet of products available. Creating these Java websites. The one I've used a lot is Tomcat. That's the Java server. But you know, it's much more complicated than Apache, but very important to learn. And I've hacked into it a few times. It has the typical range of vulnerabilities too. Anyway, so you often have common components. So you'll have authentication here, presentation layer, a database map, and logging. These are third-party components you'll add. This is why it gets really confusing. There are hundreds of different languages and hundreds of different products used to make web pages. And a company makes a decision which of these products to buy, and they get experts in them. So they use this type of software, And another company will use a whole different suite of software to make essentially the same web page. And I remember when I started learning in the 70s, we argued about what the best programming language is. There were only a few then, like COBOL and Fortran and BASIC. And we said, well, pretty soon we'll pick one, it'll be the best, and all the others will go away. And that did not happen. It just exploded. I know web developers typically know 30 or 40 languages. And I knew a guy that got all so many certifications, he shrunk them down to 3x5 and put them in a Rolodex. It's just ridiculous. Everybody just makes a new language for every application, and they all look just like JavaScript. It's enough to make you cry. But anyway, that's where we're at. So, all right. ASP.NET is Microsoft's attempt to compete with Java. So it uses this thing they invented called .NET Framework, which is supposed to be a platform-independent framework like Java, but of course it only runs on Windows. I don't know why Microsoft tried to make a platform-independent product, but they did. And .NET is good, clean, fun, and hacking .NET is bloody awesome. I've got some good .NET reverse engineering and hacking projects in the exploit development class. And it's like Java. Java compiles not down to object code, but down to bytecode, which is not real assembly code. It's a binary language which runs in a Java virtual machine. And so it does not get all the way down to the language of the processor. That's what the machine does. And ASP is similar. There's this funny looking bytecode, which is then run in effectively a virtual machine, although what's underneath it always has to be Windows. So I don't know what the point is, but they did it. Anyway, and you can write any language, which then, it's kind of funny. If you get compiled ASP code, you can reverse it to the original developer might have written in C#, but you can turn it into Visual Basic and it's fine too. It can go back to any of those higher level languages. It's kind of nuts. It's like half digested code. Anyway, I see a chat message coming in. How to do web proxy when it's HTTPS. Yes, what you do then is you either click OK in the warning saying I accept the proxy, or you import the proxy. Oh, you can hear audio? Okay, good, thank you. Yeah, I'll mute the audio. Good, thanks for telling me. That's quite common. Somebody always leaves the speaker making noise, and I guess my speakers are turned down low. Yeah, anyway, good. So you can totally approve the proxy, and you will in the project. What you want, the simplest thing to do is export the root certificate from Burp and import it into your browser. And then your browser will trust Burp and stop putting up error messages, and you can then make HTTPS connections through Burp, which, by the way, is how most companies do it now. Most companies intercept HTTPS because they don't want any encrypted traffic leaving the company. That could be company secrets. It could be violating your company policy. It could be viruses. Companies really don't want anything leaving or entering that they cannot decrypt and scan. So they typically man in the middle HTTPS with their own certificate authority, which they then add to the browser of their company laptops. Or this is something that the privacy people get all upset about. You can just put in a real certificate authority key. This is a dirty little secret of HTTPS. The whole point of it is the certificate authorities are never supposed to let anybody else have their root key. But in practice, many of them will do if you pay them enough money. So, or if you have political pressure on them. And TrustWave, one of the authorities announced about 5 years ago they were no longer going to sell their root keys. And the Firefox community freaked out and said, we can't trust TrustWave, and we're going to take them out of the list. And they said, no, you didn't listen. Read my lips. Everybody else is still doing it. We're the one that's going to quit doing it. You should throw all of them out and leave us in. But this has been the open secret all along. And one of the things that made it leak out was when the Suits and Spooks conference started, which I don't understand how it can work. There's a convention of security professionals and spies meeting together to discuss things publicly, which is kind of nuts. And they have a vendor area selling spy equipment. And they showed this stuff that they will sell law enforcement. They sell your router. It looks like a Cisco router, but it says it will intercept HTTPS. And here's a USB stick, put in the certificate there. And nobody will ever know. So obviously, cops can get real root certificates, and corporations can get real root certificates, and not officially, but you can do it. So HTTPS is not at all as perfect as it ought to be. The math is good, but in practice, people break it. Anyway, so Visual Studio is Microsoft's development environment. Yeah.
I got a certificate from Let's Encrypt.
Yeah, but that's just for one website. You can put that on your server. That's not a root certificate. All you can do is you can sign your website with it, and the URL has to match the URL you sent them. If you try to sign like Google with that certificate, it won't work. But if you had a root certificate, you could sign anybody's website with it. And that's what you need to man in the middle. Now, wherever you go, I lie to you, give you the wrong key. Your browser believes it, so I can read everything. Except for people that pin the connection. Like the Play Store in an Android phone actually uses pinned SSL, which means not only does it do the HTTPS handshake, but it knows what the certificate should be. So even if a trusted authority gives it a different certificate, it won't accept it. But that is rare. There's only a few sites using that. Anyway, so Visual Studio is the development environment Microsoft gives you to develop in their language for the Microsoft platform, and it does attempt to block common vulnerabilities, which is nice. PHP is for cowboys, originally called Personal Homepage. It's famous for making it easy to make a dynamic website fast. It's also famous for being insecure. It's not intrinsically broken. It's just that in practice, if you put up a PHP site, before long, somebody has a file upload vulnerability, and pretty soon somebody has a way to upload a script and it runs on the server, and now you got command injection. And this is why WordPress sites get hacked, because it's in PHP. In practice, PHP is dangerous and usually leads to maintainability problems and security problems quickly. But it's free and it's very easy for developers. I use it all the time because I'm deliberately making insecure sites. But anyway, this is the open source option. Linux, Apache, MySQL, and PHP is what you use if you want free software to run all your site. And this is fine for small businesses and people that are good Linux coders. The larger businesses usually knock this off and move to either Microsoft or Java to make the big stuff. And they pay highly trained programmers to use those more difficult languages. So all kinds of products are available, bulletin boards and webmail and photo galleries and shopping carts and wikis. That's the point. It's like most Linux products. It's an open source community and people can just throw something together, and a ton of them are spectacularly vulnerable. During the 2008 presidential primary, both Hillary Clinton and Barack Obama had vulnerable versions of PHP-BB. So the Barack Obama fans noticed it first, so they put a post on Hillary's bulletin board that would redirect back to Obama. So her bulletin board was down and all her people wanted to go see Obama for a while because you could totally inject a script in a page, and this kind of thing happens all the time. That's the problem when you use this free stuff. It often is full of vulnerabilities and people often don't update it quickly or they don't use the latest version. Ruby on Rails was real popular. I don't hear that much about it anymore. For a while, everybody liked it. Ruby was a language written in Japan, and it's really very elegant and beautiful and mathematical, like the original C was before C++, which is kind of a mess. And the Rails goes with it. And you can code things there, and it was fashionable for a while, and most people, I don't hear people using it that much anymore. It was considered really great for a while. And I think it's still out there to some extent. And you have to have a database somewhere. Almost all databases are relational databases, and they use SQL. These are databases designed originally for financial work. So if you all the records are synchronized. And if you have another copy of the database, it has to be completely synchronized all the time. So there is only one answer to how much money somebody has in their account. That's normally what you want. There was a movement to NoSQL databases for a while, which Facebook started, thinking that they could have a less exact database and somehow that would save them a lot of processing time by not really updating it promptly. And that became fashionable and then kind of fell down again like Ruby on Rails. I think people mostly found out that that didn't really turn out to save enough time to be worth it. But anyway, you now write queries, and you did this last time with SQL injection. You can execute code on the server by putting unusual things in fields like name and username and password if the code is sloppily written, which a lot of it is. XML is just another way to structure data going up to the web. You put it in tags. It looks like HTML. You have pet, ginger, slice pet. You have these less than and greater than signs used to define the name of a field, then data. Then you have a closing tag. It's just a way to format data to send it up to the server. But what it means is if someone was able to put a less than or greater than sign in something like a name or a password, it could be mismatched on the server, and you can have XML injection just like SQL injection, where part of what I put in as data is in fact treated as code at the other end. SOAP uses HTTP and XML, Simple Object Access Protocol. So if you want to send anything up to the server, you could say get quotation, quotation name, Microsoft, and so on. You can just have structured data going back and forth. and in this form, and it's just another way to do it with just like other techniques commonly used by simple little requests. So a response would look like this. You send a SOAP request, you get a SOAP response, and it's sending you back a structured response. All right. So if you have user-supplied data in there and you allow them to put in less than or greater than signs, then they can put code in there and you get various kinds of injection vulnerabilities. One of the more hilarious ones, well, these web service description languages shows what they have, and we'll play with this later. One of the fun ones is mobile device management platforms. There were 14 of them about 5 years ago, which are ways to remote control your cell phones, to remote wipe them. And it turned out that they used security description language, SDL, which is based on XML, and their 12 out of the 14 popular platforms had the same flaw, that you could send assertions up with SAML, security assertion markup language, and I could send 2 assertions. I could say, I am Sam, and I'm the administrator. And it would only validate the first one, and then believe them both. So you could just add extra claims to the request, and as long as the first one is signed, the rest would all go through as if they had been signed. This is a common effect of modular programming. You bring in the request, you parse it, then you go to the signature checker that checks the signature, then you go to the enforcer that implements it all, and you didn't think there might be 2 of them. So the signature checker only checked for 1. You can see how you would end up this way, just by going through steps of processing until you think about it. This kind of problem happens over and over and over from modular programming. You do a check, but the check made an assumption you didn't realize was not also made by the next step. All right, so I got some Cahoots, and they should be here. And I better turn off the proxy or Kahoot will get all upset. All right. I could approve the certificate, but I don't really want to do it. All right, here we go. So I should have favorites. There we are. And okay, so this is 129S3C, I think, which is this one. There. And that looks right. There's even music. Okay. Good. So you can do this, and I see another chat message coming in. Thank you. Okay, good, good. All right. And see if I can somehow get this thing to open. All right, let's put this at top long enough to get this open. All right. And all right. Okay, good. All right.
Planning any trips this year?
What's that?
Planning any trips this year?
Well, I had a bunch of plans, but most of them canceled because everybody in Asia is terrified of coronavirus.
Oh, crap.
So not as many as I thought I would be. All right. So I guess I'll go. I don't know why the music stopped. Maybe it will come back. Maybe my browser crashed or something. Yeah, it looks like the music died somehow. All right. So what system looks like that there? ID /ID type/type. Looks like there's a missing slash there, but anyway. All right. All right, that's XML, although that should be a slash up there, but anyway, that's what it is. All right, extensible markup language, the generic thing of which HTML is a subset. All right, so what language is used on LAMP servers? PHP. All right. What system uses WSDL? Web Services Description Language used by SOAP. All right. And what system uses POJOs? Plain old Java objects. That's what they are. All right. So, Anting looks like a real name. And Felipe. And, oh good, real names, okay. You guys will get your points without the usual uncertainty from using a real name. All right, so let's go back. We got another section of these, and then I'm going to demonstrate a Bowne scanner. So, all right, then there's client-side functionality. So the simple websites just have HTML, which is not a programming language. It's just a markup language. You can make things big and make them red, but there aren't any loops or variables or anything. XHTML is just a stricter version of HTML. The original HTML lets you make mistakes in the code, and it still uses the code. It guesses what it thinks you meant, which is why pages render differently in different browsers, and it's kind of insane. XHTML was the stricter version of HTML to try to make that less crazy, although it never became all that popular. Anyway, so you got these click hyperlinks. You have ahref something, and then you click on that. It will go to this request. It'll take what was in quotes and then build a URL out of it and send a GET request there when you click on that. So you can make a form, and your form can go to a script like a PHP script, and now you put in a name and password and click submit, and it will send this data up to the PHP script, which can then retrieve the parameters and do any kind of calculation you want on them and fetch data from a database or whatever you like. And that's the way it generally works. And as we say, there are dozens of scripting languages you can use that all do essentially the same thing. So you send an HTTP request, you get this PHP, and here it's got name and password up here in the URL, which you can do, although that is not recommended to put any secrets up in the URL because it's put in server logs and in favorites, but you can do it. Then you have the name of the host. All you really have to have is you have to have the get and the host. Only the first two lines are actually required by HTTP 1.1. HTTP 1.0 didn't even require the second line. But most of them do put in all this other stuff like refers the page it came from, and the cookie is down here with information and so on. So this is the HTTP request that's sent up. Now you can get a reply in various forms. And if you use multi-part form data, you see the encoding type over there in the request is multi-part form data. I don't really know what the point of this is, but it looks kind of screwy. The reply will now have this boundary, this long random letter, and it will then put structured pieces of data delimited by those boundary texts. I don't know why this happens, but it is a form of response you'll see used sometime. Instead of having just one body, it can have multiple blocks of data separated by those boundaries. CSS is how you make websites prettier. It gives you a more rich set of styling features than HTML. And you have things like this, your H2s are now going to be red and so on. And JavaScript is script that can run on the server or in the browser. And it begins the madness where the developer actually doesn't usually know where the script is running. And so, but JavaScript that runs in your browser is intended just to make pages dynamic. Now, the original plan was just to like change the color and make things move around a little. But about 10 years ago, Firefox and Chrome developers said, you know, why is JavaScript so slow? And they realized there was no reason at all. It was just poorly written. So they rewrote the JavaScript engine and made it 100 times faster. And suddenly you could have all these complicated JavaScripts running in the browser, but not if you use Internet Explorer, which was so slow it was pathetic. And they started making these advanced websites that looked beautiful just in JavaScript, and Microsoft was shamed into improving their engine and catching up. And now you have these heavy JavaScript frameworks like Node and Angular and everything, where people just write tons of JavaScript and it runs really fast, and it's almost like a compiled language now. And so a lot of people are really just focusing on JavaScript development as the new hotness, and these complicated frameworks built on libraries you download to make your page all dynamic. And I never cared about it. People laughed at me for my old-fashioned page before this, until they started having interesting vulnerabilities in those. Now those big platforms have weaknesses and vulnerabilities, and it becomes interesting to hack into them. So VBScript, Microsoft tried to compete with JavaScript by making Visual Basic Script. This turned out to be kind of useless and pretty much abandoned now. They pushed it for a long time, like a lot of things. Microsoft made Silverlight to compete with Flash. They try to make their version of everything, and most of them just fail, and this failed. Now, the document object model is the object-oriented structure of JavaScript, and we are going to use this to hack into Python 3-based frameworks with template injection. It is bloody awesome. So your document is the root of the tree. Then you have an HTML element up here. Then you have a body element, and then you'll have a header element and a link and so on. And so you have a tree structure. You can refer to the document and then the HTML piece of the document and then the body piece of that and then the H1 piece of that. And so you can have a multi-stage hierarchical address of every object. And that's the document object model that's used by JavaScript to refer to objects. And this is why one of my students was looking at one of my pages and he got really horrified, because my HTML, I have stuff that is just sitting there. It's not inside a container of any kind, because that's the way you wrote HTML back in the 90s in HTML2. And I just don't care, but it fouls up everything based on JavaScript, because everything's supposed to be in a container so you can refer to it. And putting things that are outside a container is like unsanitary and evil and corrupt. And they say, what's wrong with you? You don't know anything about the web page design. And I say, that page is just as good as it was in 1993. In fact, it's just the same as it was in 1993. Back then, nobody cared, but now they care. So anyway, all right, so you can make a page like this. You can put in a script here. And now instead of just putting this hello world directly there, you have a script that refers to this element, finds the element named demo, and puts it in there. So this empty paragraph is named demo, and this inner HTML JavaScript command puts text inside there. So you can dynamically fill the text. And if you play the binary games like we were doing last time, you'll see they all work this way. They're very simple JavaScript, so it does little calculations. Anyway, Ajax was the next step up, asynchronous JavaScript and XML, and here was to make dynamic pages like Google Maps. Google Maps, you can drag the map, and it updates right away because it doesn't reload the whole page. It just reloads a little bit at the top to drag it along. And so you can make a request to the server for a little piece of data, not the whole page. And so that's what happens here. If you take Google Maps and drag it down, you'll see a bunch of these requests going by, getting just a little piece of data from the map, and then another little piece, and another little piece. So it can just fill in the image at the top that I'm dragging without having to reload all the rest of it. And this turns out to be very effective. Now you have to structure that data somehow, and a lot of people structure it as JSON, JavaScript Object Notation. It's an alternative to XML. You can just have curly braces and then name value pairs separated by colons here. It's just a way to structure data. You can structure it many different ways, but you choose one way and build the server to use this kind of request and the client to use this kind of request. So if you update data, I can send a post request up to the server, and I can put structured data here, and it will now update that data on the server. All right. Now, the fundamental security barrier in the browser is the same origin policy, and this is very unsecure. And browser security is hilariously bad, and it always has been. The problem is you don't know who you're talking to. In the old days, you would go to ccsf.edu and you would connect to only one server, and all that data would come from one file on that server. So you knew who you were talking to, but now you've got scripts coming from here and little requests of XML, HTTP asking for little data from there and cookies from all over the place. And the fact is the page is not really made by content that came from only one server. And there are a bunch of tricks to fool your browser into putting something different in the URL than the actual server it's talking to. So your browser is really not sure who you're talking to anymore, But all the security relies on knowing who you're talking to. So the scripts on Facebook will only run while you're on the Facebook page, but not on the other page. And that's how we get a whole bunch of attacks like cross-site request forgery and cross-site scripting, where you trick your browser into running scripts in the wrong context. So I can go to my page, and my page loads an image, and that image causes you to buy a book at Amazon in the other tab without you knowing it, because I tricked your browser into thinking it's at Amazon when it isn't, and sending the Amazon cookie up, and you will be playing with these. These things are far too easy to do. All right, so that's the game. You normally shouldn't be able to run any dynamic content on a page except on that page. And your cookie should only be sent to the right domain, not to any other domain, but it turns out to be pretty easy to fool it in a variety of ways. HTML5 is a modern replacement for things like Flash that can let you have dynamic content all within HTML, and it just gives you more of these advanced tags so you can have rapidly updating content without having to have so many browser plugins. 15 years ago, everybody had Flash and a Java plugin and other plugins, and those things turned out to be unreliable, crash a lot, and terribly insecure, and they're pretty much all gone. Modern browsers won't let you put those plugins anymore. Instead, you use HTML5, which turns out to be better. So this is Web 2.0, where you have people logging in, user-generated content, and all these asynchronous requests, much more complicated than just loading a page and showing you one page. All these other technologies loading little pieces here and there in a more complicated and dynamic way. And here's some of those browser extensions, Java, ActiveX, Flash, and Silverlight. These tried to make things run faster because JavaScript was too slow, and they've all pretty much gone the way of the dodo bird. You don't see them used that much anymore.
Is Java still supporting the Java plugin, or no?
And most browsers, I think, will refuse to put it in now. Yeah.
Java, Oracle stuff supported.
Yeah. I mean, you'd have to get like an old version of a browser or something to put it in. Yeah. Client-side Java is pretty much over.
Thank you.
Yeah, good. Anyway, so you have stateful data because HTTP is intrinsically stateless. You send one request, you get a response, and it doesn't remember who you are. So when you go to your next request, you have to retell it who you are by constantly sending up the cookie with every request. So the fundamental protocol was never designed to keep track of who you are, and the magic cookie, which Netscape invented and added to it, is the way to add a session on top of the protocol. It doesn't define it. So that's the game here. And now the stuff you put in your shopping cart and your identity and other things are all in this cookie and are being sent up to the server. So the typical flow of a website is you go to the website, you click on links, you buy something, it stores that in a cookie on your machine, you go to the next page, it takes the cookie from your machine and sends it back up to the server, and the next page trusts it. So the data the server needs is not actually stored on the server, it's bounced off you back and forth, which leads to the obvious flaw that I could modify it and say, you could, I could buy one product and then when it comes time and pay for it, and then when it comes time to ship, I could change that to 10 products. So I only paid for one, but I really get 10 and so on, because the data is actually bouncing off me. All right, so you have to have some way of encoding this data. The most common one is URL encoding, where you just have ASCII characters sitting in the URL with a % and then a number. You can only send 32 to 127 are the allowable printable characters. All the other characters cannot be printed, and so you have to move them up as code. So %3D is an equal sign, %25 is a %20 is space, and so on. So you can put those characters in a URL or in structured data that's sent up to the server this way. All right, you should generally URL encode these characters whenever you're sending them up to a web server, because if you let them get sent in their raw form, they can be used to change the function of a web server. And that's script injection or tag injection, which we'll play a lot with. The problem with this old system was only intended to do English. But of course, there are many other languages. And the problem with those other languages, they have many more characters like Japanese and stuff. So 8 bits for a character is not enough at all. So there was this thing called Unicode that used 16 bits per character. But of course, that's pretty stupid because even that's not enough. So now there's variable length encoding. UTF-8 is the new hotness. And if you take the, if you go to B-sides, I do my Go class, go the wrong way. And in Go, all strings are UTF strings with a variable length for every character, because that's what we all should be using anyway. The original idea of putting a whole character in 1 byte was stupid, and putting it in 2 bytes was also stupid. We should have thought this through and had variable length characters right from the start, because there's no way to extend these systems to the modern world with Chinese and Hebrew and everything. This was a bad idea. Characters are not that small, and we should never have assumed that. So old languages like Python 2 go away, and you switch to more modern languages that can handle these variable length characters. Anyway, that's UTF-8 encoding, where you have as many bytes as you need to encode the character. Now you can have weird symbols like this and Chinese characters and all the things you need for the modern complex world. All right, HTML encoding has special coding for things like apostrophe and less than and greater than. You can do it this way. You can do it with code numbers, like ASCII numbers, or you can do it with these alphabetic symbols with an ampersand and a semicolon. And there are ways to express it so it will display on the screen like a less than sign, but it will never be interpreted as a special character to begin an HTML tag, which is important. So users could input data that included a less than sign, and you could manipulate it without it being misunderstood as a control character. All right, so like I say, you can just use a pound and a numerical code there instead of the alphabetical code, which is what you might do for other exotic characters. Anyway, there's base64 encoding too. This is originally designed to send images through email. You have binary data, but you're sending it through an ASCII-only medium. So what you do is instead of taking 8 bits, you take only 6 bits at a time. So there's only 64 possibilities. And so if you have 3 bytes, which is 24 characters, 3 bytes, which 24 bits turns into 4 characters of base 64. So taking 6, and all it uses is uppercase letters, lowercase letters, the numbers, and then 2 more symbols, usually plus and slash. And so any binary data can now turn into readable data, uppercase, lowercase, and numbers, and be interpreted at the other end. It does get 30% bigger. It takes 4 characters in base 64 to carry the data in 3 characters of raw binary. But it is printable and transmittable. By the way, if you like getting a headache, you can go to Bitcoin. Bitcoin uses base 58. Because they took base 64 and they removed the confusing one, like the lowercase l and the 1 look the same, and the capital O and the 0 look the same. So they took out the characters that are easily confused and ended up with 58. So Bitcoin addresses are base 58. Anyway, all right. Yeah, well, because the idea is you might write it down or put it on a business card or fax it, and you want to make it clear. Anyway. By the way, there was a theft last week where Canadians stole $50 million from Americans with SIM hijacking. There are a bunch of Americans that have millions of dollars in Bitcoins on their phone. Don't do that. What the hell? That stuff is cash. Are you crazy? If I wrote a Bitcoin wallet, I would put up an error message as soon as you had more than $10,000 and say, dude, don't put $10,000 in cash on your phone. Are you nuts? Take that off and put it in a USB stick in a safe deposit box, cold storage. Man. Anyway, people don't realize that stuff is cash. If somebody steals it, it's gone. You don't put $1 million on your phone. Anyway, it's the same as cash. If you, yeah, but if you lose it, it's gone. And if somebody steals it, it's gone, like cash. That's the thing. You can't just, if it was a Visa account, you could appeal and get it back, but that stuff is cash. You can't, people don't treat it with enough respect. Anyway, all right, so hexadecimal is another way to encode it. So capital A is 41, capital B is 42 in hex. So it's 4 times 16 plus 1. So you can just encode things with their hexadecimal equivalent. This, of course, makes them twice as long. It takes 2 characters of hexadecimal to do 1 byte. So it is simpler than base 64, which has a smaller expansion factor. Anyway, so you can have serialization frameworks. Like say you might store a bunch of data on your machine, and you might want to store it in a blob of data. So there is Java serialized objects, and there's something called Pickle that goes with Python, a way to stick a bunch of data in an object, which then comes back. And the early versions just crammed it in there with something like base 64. So all you had to do was decode it and modify it and send it back. The later versions now started having like encryption and signatures, so you couldn't modify it, because they all have this issue that I'm sending data to the client, and then the later page is getting that data from the client, and I would like to believe that the client didn't modify it. So early versions were hilariously easy to hack into. Later versions make it harder with cryptographic signatures. And all right, Anyway, this is, I thought a good, yeah, we're just at the end. This 3M, let me bring this up. This is a analysis of client-side validation. So you can't get in the door unless you do that. And that's basically what we're going to do a lot of in this class. By using something like VERP, you can just modify the data that the developer put there because they put the data in the system under your control without realizing it. Anyway, so we got another Kahoot, and then I'm going to demonstrate a new project, which I just got up again today, and I'm happy with it. So this should be chapter 3D right here. Okay. Good. We're just coming up to an hour. We'll take a break before I do the demo. All right. Should be sound. There it is. It's a free product. So I guess I can't get too mad at it for not working too well.
Price is right.
The price is right, and therefore a little defect, so I can't really complain. I was thinking if they take this down, I'd have to write my own. I did write my own for one other class, but mine is not as much fun at all.
It's a lot of code for this thing, right?
Not when I do it, but the one thing about mine is it'd be hilariously easy to hack into. Everything I write is like 10 lines of PHP, and it's easy to hack into, you know. Anyway, all right, I'll give it a few more seconds. Didn't have any of the music or the funny pictures though.
Oh, Caitlin's not. That's fine. I don't know how to do that.
Yeah, well, you can totally write a script and cheat on these, which is bloody awesome. She did. It's not subtle though. You have 1,000 identities in there, and it answers every answer as quick as possible. So one of them gets them all right and it wins all the time, and the other 999 lose. Anyway.
Caitlin and Cass.
Yeah. Well, that's what you should do. Hack everything. Hack the planet. Anyway. Yep. All right. So, what system requests data from the server without refreshing the whole page? All right, that's Ajax, applied asynchronous JavaScript and XML. All right, what system defines formats like that? P, thick, and so on. Find a type of paragraph which you call thick. That's cascading style sheets. All right. What system writes a space like that? Technically a non-breaking space. That is HTML encoding, a way to encode special characters in HTML so they won't be misunderstood as control characters. All right, and which one of these is now obsolete? All right. I worry about questions like that because maybe 2 of them gone obsolete by now, but in this case, there's only one that's obsolete. VBScript is gone, the rest are still vigorous and in active use. So Gary Lynn, all right, that's a real name. And Juggernauts isn't, they'll have to tell me who they are if they want their points.
That's Ed.
That's Ed, that sounds like Ed, doesn't he? Yeah, it's probably Ed. All right, and Ken Tan is a double winner, good. So I think you're right, that sounds like Ed. This chat message might be telling me the same thing. Let's see. Juggernaut, yeah, it is the Juggernaut. Okay, good, okay. All right, so I know who people are. Good. So it's 6:58. Let's take a break and we'll come back at 7:10 and I'll show you a couple more projects, which are good, clean fun. All right. I'm going to stop this recording and have a separate recording for the project demo.